So this is a fantastic outcome for what we've achieved with no void. And let me just tell you the backstory. I learned programming as a kid with assembly language for Commodore 16, a very simple computer back in the 80s. So my parents bought me one of these computers, and I was looking for a book to learn to program, but there was nothing. There were some basic books, but I was looking into something else, and then I came up, or I found in a library an assembly programming book or guide, and then I started getting into opcodes and operators and all that stuff. So what I did now with no void, I'm trying to summarize here the session. I asked for, I wanted to do an emulator for a Commodore 16, and I forgot the name of, or the number of the CPU. So it's a 6502. And I didn't define anything, I just asked for this. And then the LLM selected all the things that had to go in here. So we published that in a very fast way, but then we hit a bug on one of the publishers. So there was a library that was not updated in the convex backend. So we worked with that, and then we tested a Fibonacci series program. Now the amazing thing for me is that not only the program works, but we discovered a bug in the program here. So there was a jump here going to wrong address, and how we discover that is the most amazing thing, because the builds that you get from no void, apart from being extremely fast, include MCP, and we have an integrated headless browser. So that means the browser can go into the actual live application using I think it's here MCP, and you'll get the whole definition of what actions do you have here, what buttons you can click on, what can you type in, I mean, all these things. That allows the system to self update. So let's go over here on my CLI here. So we built this Fibonacci test program, but there was a bug then with the jump, and it was not working. And then I told the agent, why don't you go and try the MCP and then run a batch of tests. So what I got out of that is, let me see if I can retrieve here. Let's ask for, let me put the phone down here. Can you give me the list of tests you run on the app? So the crazy thing is that it's running like 70 different tests. The time it builds, it goes and runs all of these unit tests and end-to-end tests. And so you see that what's happening here is that you paste basically the program, and then you start going through the steps. So it goes over here and clicks on, let me just get the program. So again, I'm lost here in my screens. Let's see if I have the program here. So you see all of these tests here, all of these actions. This is kind of the test that it went through, and it says you need to call this tool to assemble, you need to call the step button so that you move on forward, and you need to read the age register and see if we can build then the Fibonacci sequence. And it goes through all of these actions. So usually when I try to work with end-to-end testing or with test-driven development, I just get bored at the first two asserts. And I say, this is crazy. I better get working and coding now instead of figuring out all the tests. But once you have a point where your AI can hold on, and it is not this one, definitely this is not the way. You can ask Claude also to click on stuff, and it's going to take hours to just do what we were trying to do here. This is instant, or it works really, really fast. Maybe not instantly, but it takes a few seconds to run through all of these tests. And it actually worked, figuring out there was an error, because at some point said, stop right here, I'm not getting this result, this doesn't correspond to the Fibonacci series, so let's go back and figure out what's going on. And then it turned out that the program was wrong. So let me ask for the program again, just to run it. Get me the Fibonacci program. Okay. So we're going to paste that. Here it is. So this is a back here. For some reason my QuickTime quit on me. This is the Fibonacci program, so I can come over here and paste it. And then I'll go over here and click assemble. And then this is the program is stored already here. And I have my registers. And I have to pay attention here to the A register. So let's run it step by step. And you'll see that it starts with 1. And at some moment it's going to be adding the series. So I have 1 and 2, and then I got 3. So when I hit this line, then I'll start getting the series. So you see X register is also updating to something. And now I got the 2 plus 3, that's 5. And then I expect to have an 8. There it is. So you see it's adding the Fibonacci series here. And this is hex, so the next value in decimal would be 13, which maps to 0D in hexadecimal. So this is just absolutely amazing to see. So how fast I got to ask for, some really complex example where you have all these asserts and then have it up and running and published. It's just crazy. So I'll see how to post this, where to share. I'm sure it's going to be interesting to follow, and perhaps to have a look at